Hello dear children, in today's class we will be starting a new chapter, that is radioactivity. Children, in this chapter we have two units. In a unit A, mainly we will be discussing about the structure of atom, nucleus, types of nuclei, radioactivity, properties of alpha, beta, gamma, and alpha decay, beta decay, gamma decay, the precautions to be taken while handling the radioactive material. And in unit A, finally we discuss the background radiations and their types. Whereas in unit B, we will be discussing about nuclear energy, nuclear fusion and nuclear fission. So these are the important topics in this chapter. So especially children, so let me tell you one more important thing. So this chapter we are going to discuss almost 5 to 6 parts actually. Children, try to understand, this chapter is a completely conceptual oriented. Means if you think that you are a bit weak in a numeric, what we can say in a numericals, so you must target this chapter. And my suggestion is that, so don't read this chapter at a stretch. So read this chapter as a parts wise, so that what will happen, you will understand clearly and you will get a complete grip on this chapter. So especially children, we will be talking about structure of atom, structure of nucleus, and we will be discussing the types of nuclei. So first we discuss about the structure of an atom. Children, we all know very well that atom is consisting of number of particles. Many particles will be there, but in that we have mainly 3 particles, so called fundamental particles. So what are those fundamental particles, children? Electron, proton, neutron. These 3 are called fundamental particles. So if you want to know about an atom, you must know about electron, proton, neutron. Let us see about electron, proton, neutron. Children, so electron is discovered by J.J. Thomson and it carries a negative charge. Means electrons are negatively charged particles and its charge is equal to the minus 1.6 into 10 power minus 19 coulombs. And its mass is negligible. But see children, so mass of the electron is negligible, it doesn't mean that 0. So it has some value. So how much it is? Mass of electron is 9.1 into 10 power minus 31 kg. When compared with the proton, so mass of the electron is equal to 1 by 1840 into mass of proton, which means what? The mass of electron is 1840 times less than that of the mass of the proton. Clear? Fine. Now come to the proton. So proton is discovered by, and children, try to understand here. So electron charge is negative, proton charge is positive, but the magnitude is same. That is, the charge of the proton is plus 1.6 into 10 power minus 19 coulombs, and its mass is 1.672 into 10 power minus 27 kg. As I told you that mass of the proton is 1840 times more than that of the mass of the electron. Clear? Fine. Now the third fundamental particle is neutron, children. So it is discovered by James Chadwick in 1932. And what is the charge of the neutron, children? No, there is no charge, which means what? Electrically neutral. So the charge of the neutron is 0. But it carries mass, children. The mass of the neutron is almost equal to the proton. Almost, but not equal, but almost equal. Look at here. The mass of the neutron is 1.674 into 10 power minus 27 kg. Now look at here. So it is 1.67. It is also 1.67. The third decimal means that much a slight variation will be there. Otherwise, so sometimes, many times what we do, whenever we will calculate the atomic mass, we will be taking a mass of the proton is almost equal to the mass of the neutron. Is it clear? So this is the information about the fundamental particles. Now we see how these fundamental particles are arranged in an atom. Children, protons and neutrons, they will reside in a small portion, so called nucleus. Try to understand, means protons and neutrons, so they will stay in a small portion, small region. This is called a nucleus. I mean what? Nucleus is consisting of only protons and neutrons. Then what about electrons? So electrons will be revolving around the nucleus. So just imagine a solar system, how planets are revolving around the sun. Similarly, electrons also revolving around the nucleus in a particular orbits. So for that orbits, we have given some names. We can call it as shells also. K shell, L shell, M shell, N, P, depends on the number of electrons, depends on the number of electrons. And here one more important thing is that children here, the distance between the center of the nucleus to the outermost orbit is called radius of the nucleus, is called radius. Very important. What is the radius of an atom? Sorry, not radius of the nucleus, radius of an atom. What is the radius of an atom, children? The distance between the center of the nucleus, that is center of the atom, to the outermost shell is called radius of an atom. So why I am saying, you may get one doubt, sir, what is the importance of knowing about the radius of an atom? Children, the size of an atom is determined by the radius of an atom only. If more is the radius, obviously more is the size. If less is the radius, obviously what we can say, less is the size of an atom. Is it clear? Fine. And here one more important thing is that then how many number of electrons can accommodate in each and every orbit, children? So for that, so we use 2n square formula. So this is a number of electrons which can accommodate each and every shell. Each and every shell. So for K shell, n is equal to 1, which means what here? In a K shell, 2 electrons can accommodate. In a, if you can see in L shell, as n is equal to, here 8 electrons can accommodate. Whereas in a M shell, if you can see, 18 electrons can accommodate. Whereas in N shell, 32 electrons can accommodate. This is how we can calculate the number of electrons which can accommodate on each and every shell. And here one more important thing is that, children, here, as long as the electrons are revolving around the nucleus in these particular shells, they neither lose energy nor gain energy, which means what here? The energy remains constant. That's what these shells are called stationary shells. Very important. Stationary shells. Stationary shells, which means what? As long as the electrons are revolving in these orbits or shells, they neither lose energy nor gain energy. That's what we can call these shells as stationary shells or stationary orbits. Is it clear? Fine. And children, here one important point we need to understand. So here we discuss about the mass of the electron, mass of the proton, mass of the neutron in terms of kg. But children, here even we can understand we can express the mass of the fundamental particles in AMU also. So this is very important to understand. Very important to understand. Look at here. What is that? I said it's AMU. AMU. So what is AMU, children, here? Atomic mass unit. Atomic mass unit. So even sometimes we only can express U only. With U also you can understand atomic mass unit. So before going to see the value of the mass of the fundamental particles in AMU, first we need to understand what is AMU. So children, to understand this, let us take a carbon C612. One atom, let us take one atom of carbon C612. So don't you think that it has some mass? Obviously it has some mass. It has some mass. So whatever the mass that a carbon C612 has, let us divide that mass into 12 equal parts. For suppose, just to make you understand, so let us think this total is a mass of the carbon. This much won't be that big, just to make you to understand. Think that this is a total mass of this carbon atom. Now make this mass into 12 parts. Mass into 12 parts. Okay, that's fine. So 1, 2, 3, 4. Am I clear? Now each and every part has equal mass, right? So this mass of each part is equivalent to the 1 AMU. Equivalent to the 1 AMU. Is it clear? So which means what here? AMU, 1 AMU is equal to 1 by 12th part of mass of C612. C612. Is it clear? So almost which is equal to the 1.67 into 10 power minus 27 kg. 1 AMU is equal to, approximately I am talking, approximately. Is it clear? Fine. Now let us express the mass of the electron, mass of the proton, and mass of the neutron in AMU. So how much it will be there? Look at here. So here mass of the electron in AMU, which is equal to 0.000542 AMU. 542 AMU. Mass of the electron in AMU. Whereas mass of the proton in AMU 1.00727 AMU. Is it clear? Fine. Next, mass of the neutron, this will be 1.00867 AMU. Is it clear? Okay, na? So if you want to know the mass of the what we can say fundamental particles in kgs, yes, this is how these are the values of the mass of the fundamental particles in kg, whereas these are the mass of the fundamental particles in AMU. Is it clear? Just copy it. Now we see the structure of nucleus. Structure of nucleus. Children, as just we have learned that protons and the neutrons, they will reside in the nucleus. Okay, na? Fine. So now let us take a nucleus. Children, don't expect that nucleus will be this much size. Just we are keeping zoom and we are learning. Okay, fine. So here is a nucleus. In this, neutrons and protons will be there. Am I clear? So neutrons and the protons will reside within the nucleus. Children, what is the charge of the nucleus? So before that, let us recall about what is the charge of the atom, children. Atoms are electrically neutral. But what is the charge of the nucleus? If you can see, neutrons are electrically, there is no charge. Protons have positive charge. So which means what here? The charge of the nucleus is due to the charge of the proton. As protons have positive charge, obviously nucleus is always positively charged one. Is it clear? Fine. So inside of the nucleus, and one more thing here, what will be the size of the what we can say nucleus? Before that, let us see once again what is the size of the atom, children. So atom size here, atom size is nearly 10 power minus 10 meters. Okay, na? So the size of the atom is in the order of 10 power minus 10 meters. But what about the size of the what we can say nucleus? The nucleus size is very important, children. The size of the nucleus is almost 10 power minus 15 to 10 power minus 14 meters, which means what here? See, the size of the atom is very much greater than that of the size of the nucleus. So if you can see the size of the nucleus, is almost 10 power 5 to 10 power 4 times less than that of the size of the atom. Is it clear? Fine. And who will decide the size of the nucleus, children? Yes, number of protons and the neutrons will decide the size of the nucleus. Okay, fine. And here we need to understand one important thing, children. Very important here. What is that here? Number of protons. Let us concentrate the number of protons. So why we need to concentrate the number of protons? Because the number of protons within the atom only will decide the position of the atom in a periodic table. Is it? It's very important. So based on the what we can say proton number only, the place of the atom is decided in the what we can say periodic table. Fine, children. And here let us see what is atomic number. What is atomic number? Children, atomic number is represented with a letter called Z. What is the atomic number? The number of protons within the nucleus of an atom is called what? Atomic number. So it's a number of protons. Number of protons within the nucleus of an atom is called atomic number. Is it clear? Fine. And here neutrons and protons together we can call it the nucleons. So it's a very important examination point of view. So neutrons plus proton together we can call it as a nucleons. We can call it as a nucleons. So this how many number of nucleons will be there? That only we can call it the mass number. We can call it as a mass. We can call it as a mass number. Children, what is a mass number here? What is mass number? Fine. So what is a mass number, children, here? So the number of nucleons. Number of nucleons, we can call it as a mass number. This we will represent with the letter A. So mass number can be expressed like this. It is nothing but the number of what we can say protons plus number of neutrons. Number of protons we can represent with the letter Z plus number of neutrons. So this is how we can calculate the mass number. If you know the what we can say mass number and if you know the atomic number, then how can we calculate the neutron number, children? So neutron number n is equal to A minus Z. So this is how we can calculate. Is it clear? Fine. And here one more term we need to understand. With that only many students will get confused. We learned about the mass number. Then what about atomic mass? Come on children. What about atomic mass here? Atomic mass. So many students will think atomic mass and a mass number, they'll think as the same, but not children. That is wrong it is. So mass number means what? Just how many number of nucleons are there. How many number of nucleons are there. But what about the atomic mass, children? The total mass of the nucleons. I mean what? Each and every what we can say nucleon has a mass. Yes, for suppose children, MP is the mass of each proton. Just example I am telling you. And Mn is the mass of the each neutron. Okay. If I want to calculate the total mass of the protons, then mass of each proton into total number of protons. Clear? Fine. And if I want to know the total mass of the neutron means what? Mass of each neutron into total number of neutrons. You may get one doubt. Sir, why are we not considering the mass of the electron? So mass of the electron is negligible. So the mass of the atom is maximum is only due to the mass of the protons and the neutrons. Now you can add these two. You will get the atomic mass. That is how much children here? Z into MP plus N into Mn. So how to calculate N? A minus Z. So this will be Z MP plus A minus Z into Mn. So this is how we can calculate the atomic mass. Try to understand. Mass number means just the number of neutrons and the protons. Atomic mass means what? We have to add the mass of each nucleon so that we get the atomic mass. Is it clear? Okay, fine. Now children, we see the types of nucleus. Hope it is copied. Children, when you go for competitive examination, this is very important to understand. Of course, in higher class, especially in 12th class, you will be learning about this in detail. Clear? Fine. Now, we see the types of nucleus. Types of nucleus. Children, look at here. Nucleus and nuclei. What is the difference here? Don't get confused. Nucleus is a singular, nuclei is plural. So I think I said wrong. Types of nucleus is I shouldn't say like that. So what is that? Types of nuclei is right actually, not a nucleus, because nucleus is a singular, nuclei is a plural. Clear? Fine children. Now the first one we will learn about isotopes. We will learn about isotopes. So let me highlight one letter here, P. At the end I will tell you why one particular letter is highlighted. Isotopes. So let me give you an example, then you will understand what actually isotopes are. So first example, let us take here H11, H12, H13. Is it clear? So actually, if you can see, these all are the hydrogen only. Okay, now it is called protium, deuterium, tritium. Am I clear? Protium, deuterium and tritium. Okay, what is the common thing in this? These all are having, look at it, atomic number is 1, atomic number is 1, atomic number is 1, but they are differ in mass number. Okay, fine. Let us take one more example. Let us take a carbon C612, C613, C614, and here also atomic number of these three atoms is same only, two nuclei is same only, but whereas mass numbers are different. So then what are isotopes, children? Here the atoms which are having same atomic number but different mass number are called isotopes. Is it clear? What are isotopes, children? So here atomic number must be same. Atomic number is nothing but what? Number of protons, P. That's what I highlighted, P. P for proton. Proton number is nothing but what? Atomic number. So atomic number is same whereas mass number is different. Such atoms are called what? Isotopes. Even we can see one more example also. Uranium 92 234 and uranium 92 238. So these all atoms, I mean individually. If you can see all atoms having same atomic number, different mass number. These atoms same atomic number, different mass number. Same atomic number, different mass number. Such atoms are called what, children? Isotopes. Clear? Fine. And here there are two types of isotopes, children. Very important to understand. There are two types of isotopes. So let me write isotopes. So there are two types of isotopes. What are those? So here we have stable isotopes and here unstable isotopes. So on what base we decide whether the isotopes are stable or unstable? Children, it means it is decided by the number of protons and number of neutrons. In a particular atom, in a particular isotopes, if number of protons are equal to the number of neutrons, then such an isotope is stable isotope. Let me give you example. So let us take C612. So here what is the atomic number here? Atomic number is 6. It is nothing but proton number. 6 protons are there. So how to get the number of neutrons? This is A minus Z. So this is 12 minus 6. So this is 6. Look at here. So number of protons are 6, number of neutrons are 6. So if the almost, sometimes it may not be exactly equal. If almost equal also, they are stable. So the isotope in which the number of protons are equal to the number of neutrons, then such isotopes are stable one. Comes to isotope means unstable one. If the number of neutrons are greater than that of the number of protons. Number of neutrons are greater than the number of protons. Let us take the same carbon isotope only to understand. That is C614. Here number of protons are how many, children? Here number of protons are 6. But number of neutrons here 14 minus 6, that is 8. So here number of neutron is greater than that of the number of proton. So such isotopes are radioactive in nature. That's what this what we can say unstable. Stable I wrote, spelling is wrong, it is okay. So it is unstable. So these unstable isotopes are also called as radioactive isotopes. Radioactive isotopes. Clear? Fine. And here one important point to be noted down. So there is a specialty for a tin stannum. What is the specialty? So this is an element. This is an element with the highest number of isotopes. How many, children? 10. So this question might be asked. This question. So name the element which has highest number of isotopes and mention. So that is a tin has highest number of isotopes. How many, children? There are 10. Okay, na? So this is about isotopes. Okay, just copy it. Fine. Now second type of nucleus is isobars. So here also I highlighted a letter A. Let us see after that. So children, let us take a example here. Yes. So look at here. Carbon C614 and nitrogen 714. Children, if you can look at here carbon and nitrogen, so they differ in what? Atomic number, but both will have same mass number. Such atoms are called isobars, which means what? The atoms with a different atomic number but same mass number are called isobars. Okay, fine. So here let us take one more example. Children, this example is a very important and interesting also. Look at here. What is that here? Let us take a sodium 11, 23, magnesium 12, 23. It's very clear. Yes. So here these two also isobars only. But for these isobars, one special name is there. What is that? So before going to see that special name, let us see actually what is that specialty in these two isobars. So children, for this sodium, if you can see, number of protons are how many? 11. Number of neutrons, how many children? 23 minus 11 will be how much? 12. Okay, now fine. Whereas when come to the here, how many number of protons are there? 12 are there. Okay. And the number of neutrons, look at here, 23 minus 12. 11. Children, did you notice the speciality? Got it? Yes, here. So what happened? Number of protons and number of neutrons are interchanged. So it appears as if, for example, we are looking into the mirror. What happens? Left hand appears like a right hand appears like a left hand. So similarly here, proton number will become a neutron number. Oh, here neutron number will become a proton number. So like mirror images. That's what these isobars are called. Mirror isobars. Very, very, very important. Mirror isobars. Mirror isobars. Is it clear, children? Fine. Why I highlighted letter A? A stands for mass number. So mass number is same. Okay, fine. Now the third one, that is the last one, is what, children? It's a isotones. So in this, which letter should we highlight? Okay, look at here. Isotones. N highlighted. N. Let us see the example, children, here to understand this. So here silicon atomic number is 14, mass number is 31. Phosphorus atomic number is 15, mass number is 32. Now here, children, if you can see, atomic numbers are different, mass numbers are different. Then what is the similarity? If you want to understand that, let us calculate the number of neutrons and see here. Okay, children, here number of neutron is nothing but, children, mass number minus atomic number, that is 31 minus 14. This will be 17. Neutron number is 17. And here also, if you can see, number of neutrons are equal to 32 minus 15 will be how much, children? 17. Yay! Which means what here? Number of neutrons are same. That's what we highlighted letter N here. Letter N. Is it clear? Is it clear? Try to understand. Means the atoms with a different atomic number, different mass number, but having same neutron number are called isotones. Is it clear? Fine. So these are the types of nuclei. Children, in isotopes, we highlighted letter P because number of proton. In isobars, we highlighted letter A. Mass number is same. In isotones, we highlighted letter N, number of neutrons. So PAN card. If you can remember PAN card, then you don't have any confusion in remembering the answers of isotopes, isobars and isotones. Okay, children, fine. So these are the important topics today I thought of discussing. So in the next class, we will be discussing about the properties of alpha, beta, gamma. Children, as I told you that, so we are going to see this entire chapter as almost 5 to 6 parts, small portion which will make, so that it will be very easy to you also to watch, so that you can learn. Okay, children, thank you so much. All the very best.